Welcome to Altair Engineering Training and Support. In this video, I'm going to show you how to create 3D meshing on Knuckle. So we'll start with click on Hypermesh to open the Hypermesh GUI. Then from the Preferences pull down menu, select User Profile and make sure your user profile is set to Radius Bulk Data. Click on OK. Then click on Import icon to import the IGS or CAD file of the knuckle structure. Select the file type. On the format you have the knuckle structure. So I have IGS format file. So I will click on file type as IGS. Click on folder to browse the appropriate file from the location and click on open. Then click on import, keeping all the other parameters as it is, and click on import. This will import the IGS file. You can see my knuckle structure has been imported. So now on the model browser you can see one component is created automatically where my surfaces are there. It doesn't contain any meshing, that is no elements and nodes, but it contains surfaces. So to view this in the shaded geometry, you can click on this shaded geometry icon. So to do a 3D meshing, your structure has to be completely enclosed volume. If there are any free edges or any free space, it will not, the 3D auto mesh panel will not create a 3D tetra mesh on it. So first I need to have a geometry editing before going for the 3D mesh. So I'll go by step process. So my first step is to delete the solids from my geometry. For the 3D auto mesh panel, as you can see, go to 3D tetra mesh, volume tetra. You can see you can either select surfaces or solid for the 3D mesh, and it always asks you for the enclosed volume. So your geometry has to be an enclosed volume, or it has to be either surfaces or solid. It will not generate the mesh on the combination of both. So first of all, go to delete panel. From the drop box, click on the right arrow and select solids and delete all these solids which are existing on this. So your complete geometry will be only surfaces. Now my next step is to make this as a complete enclosed volume. So I'll click on visualization icon. You can click on this visualization icon. I'll explain you what are these edge represents. Red color edge represents free edges. That means on this edge only one surface is there. Green color edge represents shared edges. That means on this particular edge two surfaces are passing through this particular edge. Blue color suppressed edge represents that this edge will not interfere the surface sharing. It is suppressed. We can now later on we can retrieve if we want. Non-manifold edge represents that this surface, this particular edge is shared by 3 or more surfaces. So as I already told you, we need to have an enclosed volume. So we have to remove all the free edges, and if there is no T connection, then also we have to remove the non-manifold. So I will show you how to remove them. So first I will start with the free edges. So I will make it in the line mode. Here you can see there are many surfaces. There are few red edges are there, as you can see. So I'll remove one by one. So there are different options available in Hypermesh to remove these red edges. So I'll again on all these different edges. Also I'll click on the shaded geometry icon to view the geometry in the shaded mode. Then I'll go to geometry quick edit panel, or we can click on F11 from our keyboard to enter to quick edit panel. This is the short key for it. Then select toggle edge radio button. This icon is used to suppress the edges, to toggle down the two edges with the gap less than 0.1 mm. So if the gap is less than 0.1 mm, it will join or merge these two edges. If the gap is more than that, it will not merge these two edges. So I'll one by one click on all these edges which are showing red in color to merge them. So you can just left click on that edge, it will automatically merge those edges. So here you can see the gap is more, so it's not completely filling it. Here you can see the here the surface is missing, that's why it cannot stitch it. So there is some options available in HyperMesh through which you can create the surfaces. So I'll show you that. Before that, I'll quickly again check whether this is the only edge is missing or there are some more edges are there. So as you can see, only this particular red color edge is there only. So now I will show you how to create the surfaces, the missing surfaces. So to create missing surfaces in HyperMesh, go to geometry page. In geometry page, click on surfaces. In geometry page, click on surfaces. In surface panel, click on this icon to select the ruled command to create the surfaces. There are different commands as to create the surfaces like spline, filler, ruled, skin. So you can create any one of them. So I am using ruled. Select the first line, select the second line and select the curved line below that and click on create. So you can see here it will create a surface for this curved region. So if I click reject and instead of selecting the curved edges, if I select the straight ones with the same process and say create, so you can see it creates a straight surface with these two lines. So for the curved areas, always select the curved regions, the curved edges to create the surfaces. I will again click on the first line, then the second line and say create. So in this way it has created the surfaces. Then I click return to exit the surface panel. Then again I will off all these, make it in a line mode and check whether there are any free edges are there or not. So you can see there are no free edges on my geometry. Now my next is to have the non-manifold edges. I'll just check first whether it is a T connection or not. If it's not a T connection, that means it is a duplicate surface. So I have to delete one surface to avoid the duplicate meshing on that particular surface. So I will again on all these and you can see on this area, as I can see there is no T connection. So definitely this is a duplicate surface. So I will go to delete panel again and from the drop box select surfaces and select one of the surface and just delete it. So you can see it has converted into green. Again I will select another one and say delete. So it has converted into red, that means this is not a duplicate one. So I'll select the bottom one and say delete. So now you can see this is the duplicate. Similarly this side I will also select the surface and say delete. So in this way you can delete the duplicate surfaces. Again I will off these two and check whether is there any free or non-manifold edges on my geometry. So as you can see there are no free or non-manifold edges on my geometry. So my geometry is perfectly fine and ready to mesh. So I will click return to exit the delete panel. If there are many steep joints here, where you think these are not necessary, or it may create some problem during the mesh, so you can remove them. uh, just like you can see, this point can create an problem for the meshing, so I will just remove these two areas. So go to quick edit panel again, geometry quick edit, create from this node to this node, and from this node to this, and just toggle these two. So now it will create meshing from this side to this side directly. Similarly, from this node to this line, you can create one line surface and just toggle this one. So any sharp areas where you can think it can affect the meshing, so you can remove these like this. These are the two parallel very close lines, so I will remove one. So in this way you can remove or edit some of the geometry parameters to improve the mesh quality. As you can see in this region, it may affect the meshing because of the circular. Similarly this region also. So I will just toggle these two. Similarly on this end also I will create one. From node to line also you can create from node to this line, and from this node to this line, and from this node to this line, and you can remove this one. So now it will pick all this complete surface and will not create small elements around this region, so the element quality will not fail. So these are the some options through which you can edit the geometry. Here also, as you can see, I will create a node to line and just remove this. Now I'll enter to meshing of this. Same in this side also. I will just toggle this. So I'll click return once my geometry editing is done. Then I will click on 3D page to enter the 3D auto mesh panel. Go to 3D mesh, 3D page. In 3D page, select tetra mesh panel. In tetra mesh panel, select volume tetra. In the enclosed volume icon, from the drop box, select surfaces. Click any one surface of your component. It will pick all the surfaces automatically. If there are any free edge, I'll create one free edge and I'll show you. If there is any free edge or duplicate edges are present, you can see here on the same panel, it will not select the complete volume, as you can see. So it has to be an enclosed volume. So you have to create the enclosed volume. So you can see here it has picked all the surfaces. Then select the 2D type as R trias because it captures the fillets, the curved regions more accurately. Select the 3D type as tetras. Select element to current component. Check the box in front of use curvature and use proximity. You can enter any minimum element size. Say for this model I am using element size, minimum element size as 0.5, average element size as 4, and feature angle as 30 degree. Feature angle stands for the normal angle between the two elements around the curved features. So lesser the feature angle, denser will be the mesh around the curved areas. and then click on mesh. Once you click on mesh, it will start generating the mesh for the structure. Now you can see my model has been meshed with the 3D meshing. So I'll click return to exit the tetra mesh panel. I will off the geometry so that my elements are only visible. You can see. If I go to mask panel and mask a bit of it, so you can see in this way it has created a solid volume tetra mesh. Now I will check the quality of this tetra mesh. So to check the quality of 3D tetra mesh, go to tools, check elements, click on the warpage and aspect. You can see none of the elements are failing on aspect and warpage. Then click on TET collapse. TET collapse stands for the height of the tetra element. So if the height is very less, so the tetra element will tend to behave like a 2D mesh, 2D element. So that's why it should have a proper appropriate height. Acceptable value for TET collapse is 0.2. So to show how you can remove those TET collapse from your geometry, I'll just improve that to 0.3. So first click on TET collapse. So on the bottom you can see 4 out of 25 917 elements are failing. So then click on save failed to save all the failed elements. So it will say again the highlighted elements have been placed in user mark. So these elements have been saved and placed in the user mark. Then click on mask panel. From the drop box select elements. Make sure the radio button is mask is selected. From the drop box select elements. Click on the elements and say retrieve. Again I'll show you. From the drop box select elements. Click on the elements and say retrieve. It will retrieve all the 4 elements which has been saved. That is 4 elements added by retrieve. Total 4 selected is 4. So it has selected all the 4 elements which are failing. Then click on elements and say reverse. So it will select all the other elements apart from that 4 failed elements and click on mask. So now you can see on your GUI only those elements are displayed which are failing in the TET collapse. Then press Shift plus F2 from your keyboard to enter to temporary nodes panel and create a nodes around the tetra elements. Or you can enter to geometry, temporary nodes, Shift plus left mouse button and drag it to drag a window to select the nodes. Then click on add, it will add the nodes. As I already told you that TET collapse is the height of the element of the tetra element. So as you can see for this particular, the height is very less as compared to its base and hypotenuse. So either you can decrease the hypotenuse length or increase its height. It will improve the TET collapse. So press F10 to enter the quality check panel. F10 is the shortkey for tools check element panel, that is this one, tools check elements. This is, if you press F10 from your keyboard, this is the shortkey. If I click on this element, you can see its TET collapse is coming as 0.276. So now I'll show you how to improve it to more than 3. Press F4 from your keyboard or go to geometry distances. F4 is the shortkey for distance panel. To improve its height, either we can reduce the hypotenuse or increase the height. So first I'll show you how to uh, improve the TET collapse by changing the hypotenuse. So select the node 1 and 2 and change the distance from 3.7 to say 3. Again press F10 from your keyboard and check. The TET collapse value has decreased. Now I will see how to improve or increase this height. So to improve this height, press Shift F4 from your keyboard. I will use translate command. Shift F4, Shift plus F4 is the short key for translate. I will pick this node, create a plane. On perpendicular to that plane, I would like to translate it as a 0.1 distance and say translate. Then again I will press F10 from my keyboard. You can see its value increased from 0.22 to 0.297. I will again press Shift F4 from my keyboard, again pick this node, select 3 nodes to define the plane and again click on translate and just check it again. Okay, this has increased to 0.3. Now I will click on mask icon and mask this and then press Shift F2, select this node and click on clear. Instead of clicking on clear all, I will say clear. So only my field elements are here on my screen. So now you can see this element is also failing due to the height. So I'll press Shift F, press F10 from my keyboard and check what is the value of these 3 elements TET collapse. As you can see, it's 0.273, 0.274 and 0.274. So again I will press Shift F4 from my keyboard, pick the center node and increase the height a little bit. Again press F10. You can see it is passing all the TET collapse. All the 3 elements are passing. Then I will click on unmask all icon, this to unmask all the elements. Then I will press Shift F2 to and click clear all to remove all the nodes, temporary nodes which I have created. Then I will click on TET collapse again. Now you can see only one element is failing at 0.29. So again I will repeat the same process. Click on save field, go to mask, elements, retrieve, reverse and mask. Press Shift F2 from my keyboard, add the nodes. You can see this is the distance, that's why it is failing. So press Shift F4, pick this node, create a plane and just translate it. So now I check it is passing through. Then again click on unmask all, Shift F2 and clear to clear these nodes which I have created to improve the mesh quality, the element quality. Again press F10 from my keyboard and say TET collapse. So now you can see all my elements are passing the TET collapse value as more than 0.3. So for tetra element, the maximum point is to clear the TET collapse. Then the minimum angle, it should not be less than 10 degrees, or say it's better to have a good like 15-degree angles. Then maximum angle is 120 degree, it's good. So in this way my quality of the elements are perfectly fine for the meshing. Now I will just go for the free run to check whether my elements are passing or not, or is there any elements which are failing in the quality checks, through which it may affect during my main run. So I'll quickly go for the free run analysis to check mesh qualities and parts connectivity also. So I'll follow that same process, MPCLL. First I'll create material as steel, define the color, select the type as isotropic, card image as mat1, click on create edit, enter the values of e, new and row, then select the property, enter the name of the property as knuckle, select an appropriate color. This time, as I have a 3D elements, I will select element type as 3D, card image as P solid because we have a solid elements, material as steel, and click on create. So this will create my material and property. Now I will update the component with appropriate material and property. So I will click on component icon, then I will click on update, click on comps and select the component which I want to update. Click on the toggle button and from no property I will toggle it down to property. Select the knuckle property which I have created and click on update. So by element view you can see the element color mode, you can see my all the elements are assigned with proper property and material as it's changing the color. Now I'll create a load collector as EIGRL to define the frequency range for the normal model analysis, that is the free run. Click on create edit, enter the values of initial frequency, maximum frequency and number of modes, then click on return. So on the model browser you can see my load collector has been defined. Then I'll go to analysis, load step, to define the load step by defining the type of analysis I want to perform. I'll enter the name as free run, select the type as normal modes, check the box in front of method structure and select the EIGRL and click on create. So this will create my load step. Now I will save this file and run the analysis using Radios. So click on analysis, Radios, select the export option to all, run option to analysis, memory option to default, click on save as to save the FEM file and then click on Radios. So in this way you can see my analysis has got completed. Then I will click on results to view the results in hyperview to check all the components are properly connected or not. So you can see this is the model analysis results. So I will just see the animation plot. So to see the animation plot, go to linear static animation mode and say click on play. So you can see if this type of component is moving, that means this is completely connected. You can also change the modes. So you can see in this way. So in this way I have ended the tutorial, that is how to do 3D meshing of the roll cage structure, how to edit that, how to improve the mesh quality, how to first edit the geometries, remove the solids and do mesh additions and then perform a free run so that you can perform all the different types of analysis which you want to perform on this roll cage structure. So in this way I have ended this tutorial.